for teachers, who's listening, who's not. All right, let's go ahead. And again, you should not have anything there because you wrote this up at the top. So you guys okay if I erase this now? Yeah. Yes, okay. So remember that should be up at the top. All right, so the first thing I'm going to find is my radius. The question in number 1 says we are revolving this region. So this is, if you want to call this region R. All right, this region, we're revolving around the x-axis. Or another way to think of it is that's y equals 0. Okay, so you're going to get a lot of practices with this tomorrow if you're in my class, because you're going to actually visualize doing it. But the idea is if you were to take this and revolve it around, it creates a 3-dimensional figure. All right, now the reason that this is called the disk method is because do you see how there is no gap between the axis of revolution and my shaded area? If there's no space there, then there does not create any space in the shape, the 3-dimensional shape.
The axis is like the middle?
In this case, the axis that we're revolving around is the x-axis. Exactly, we're going to spin it around there to make a shape. All right, I think you'll get a better idea of this after tomorrow. Okay, because you're going to practice that. All right, so the reason it's called disk is because there's no gap there. On Friday, actually maybe not Friday because I might do the review of our last test, but the last link for this lesson 6.2 is called doing the same thing but with the washer method. And the reason it's called the washer method is because you guys know what a washer is? That has like the little hole, and it's like a circle that has a little hole in it, like a donut, right? So the washer occurs when you have a gap between your shaded area and the axis of revolution. So when you revolve it, it creates that little kind of hole in the middle or a washer. So that's why I call it the washer method. That's coming, right? That's not today. That's even more complicated than this, okay? All right, so let's find our radius, which is the distance from the axis of revolution. What is the axis of revolution? No, y equals 0, right? Y equals 0, so 0 minus, all right, and what is my function? Is it x cubed? It's x cubed. Okay, so if you wanted to simplify that, you could. All right, so what is 0 minus x cubed? Negative x cubed. Now, the formula that we're going to use today for the area, all right, is the formula for the area of a circle. Do you guys remember that formula for the area of a circle? Pi r squared. Exactly, Bernadette. Pi times the radius squared. All right, so we just found r, right? Our radius is going to be this negative x cubed, this distance here, right? If you don't think of it like this, right? This distance is going to be our radius, okay? And we are going to integrate this area to find the volume. I'm going to repeat that. We're going to integrate this area to find the volume. So what you're going to do to find the volume is you're going to write down the integral. What are my limits of integration? 0 to 2. All right. And I'm going to write down pi times my radius squared. Remember to ask a question. If you're confused by something, it's the first time you've done this. Why is it, cubed? Because this curve here is x cubed. So if that function would have been x to the 4th power. Why is it? Because we are doing this formula for the area, which is the radius squared. You're good. Okay, now I'm going to clean this up a little bit before I start doing the calculus. Do you guys see this pi that's in front? Where am I going to move that? In the front of the integral, right? I'm obviously going to do that, make my life easier. And then what am I going to do when I square that negative x cubed? What is negative x cubed squared? Positive x, I heard somebody say to the 6th power. Remember, a power to a power means you multiply. Power to a power means you multiply. Right? Take you back all the way to your pre-algebra days. Okay, now at this point, that's all the new stuff. What I do the rest here is not new. Is everyone okay with the new stuff? Okay, so let's do the antiderivative of x to the 6th power. So how am I going to do that? Exactly. I put x to the 7th power. I add 1, and Bernadette is right. I put the reciprocal in front of that. The reciprocal of 7 is 1/7. All right. This is my antiderivative evaluated at 2, and 0. Now, don't forget, because it's going to happen. All right, don't forget. Right now, what am I ignoring? But I'm going to bring back in at the end. Pi. So just be careful. A lot of my students last year, some of my students last year, would get an answer wrong in Delta Math. They're like, what the heck? I did it right. I'm like, did you multiply by pi though? And they're like, no, I didn't. All right, so don't forget that this pi will eventually multiply by that whole thing. Okay? So we're doing that f of 2 minus f of 0. Why is this making me happy?
0.
Because I see 0, and if I see 0, I want to make this very clear. Just because it's 0 doesn't mean it's happy. I'm happy because if I plug in 0 to this x to the 7th power, I get 0, right? 0 times 0 times 0 times 0 times 0 times 0 times 0 is 0. All right, so that is fine. That's all 0. So really all I have to do is do pi times 1/7 times 2 to the 7th power. Does anyone happen to know 2 to the 7th power? Okay, we can do this though. What's 2 to the 3rd power? The 4th power? 128. Oh my gosh, we did it. Hello. So I'm going to write down 128 pi over 7. This is my answer. Now, if this was Delta Math, what am I going to do to get the answer? Change it into a decimal. So do 128 times pi over 7. And I'm going to use decimals. That's what I recommend for you guys. It'll be this. On the AP exam, it'll be that. Yeah. They have no problem with pi in the answers.
Wait, I have a question.
Yes.
The first part, why do you subtract it from 0?
So I always want you to think of, remember the phrase you wrote down at the top? I just erased it. But you should look at your paper, and at the top should say the radius is equal to the distance from the axis of revolution to the function. So the axis of revolution, Georgie, is y equals 0. So that's why it's 0 minus this curve here. Because that would give me the distance between the two.
Then why is it negative? Like, why do you...
If you would like, I'm not making it negative. If you would like to do the function minus the axis of revolution, you'll get the same thing. If that's better for you. In my experience, because of what's coming with the washer method, I think doing it this way will give you better success when we make it harder with the washer method. But the reason I'm saying either way is fine, because remember, what am I doing with this radius? I'm squaring it. So if you did x cubed minus 0, you still get x to the 6th power. So neither is better, but I prefer this way because I see students do a better job when I do the washer method. Okay. Number 2, great question, Georgie. Thank you for paying attention. Number 2, all right. I think one of the hardest parts when I've been doing these problems to prep for this class is just knowing which one is the x-axis and which one is the axis of revolution. Just be careful here, right? Always look for that little x. This is the x-axis. So what is my axis of revolution? Y equals -2. It's always going to say it in the problem as well, right? So you've got this region R that's being revolved around y equals -2. So to find my little r radius, right, to find my radius, it's the distance from the axis of revolution, which is -2, minus my function. So this distance here. And what is my function in this case? Notice the parentheses I put, because we are subtracting the whole thing. So if we clean that up, that's going to be -x squared. And then what is -2 minus -1?
-1.
It is -1. So this is my radius. Any questions on that? Okay. Now I'm going to do what with this radius? I am going to square it into putting in the area formula. It's going to be squared. So let's do a little math over here to the side where I have to square this. Does anybody remember how to square this without writing 2 separate binomials? Do you remember the process to square this?
Multiply and then like add star.
Integral.
To multiply the first one.
Oh, somebody said 2ab. That's nice, Anita.
That's in the middle.
That's in the middle. Oh, no one ever remembers the middle, Anita. They just care about the beginning and the end. Nobody cares about the middle, so thank you. All right, let's do the beginning. What's negative x squared squared? Positive x to the fourth power, right? Because we are squaring it. Okay, let's do the end, because everyone always does the end before the middle. I don't know why. Right? What's negative 1 squared? 1. So Anita is right. A lot of my students just write x to the fourth power plus 1. This is not right. We have to have the middle term. So here's how you do it. You multiply what's negative x squared times negative 1, positive x squared, and then you double it. So times 2. So what's x squared times 2? 2x squared. Gosh, Anita, thank you so much for being here. I'm glad you did not go to the bathroom during this one. We would have missed that for sure. This right here is my radius squared. So now when I find the volume, I need to do pi times, notice how I put that pi in front right away. Okay, what are my limits of integration? Bless you. 0 to 2 again, 0 to 2 again. It won't always be 0 to 2. Spoiler. All right. Times the radius squared, which is x to the fourth power.
You squared again?
No, I've already squared it. I apologize. Let me make sure that I don't mess you up, Alan. So remember the area is, you're good, pi, I want to say it for my subscribers, right? Pi r squared is there. There's pi. I love the giggling as I say that. Sad. And this is radius squared. I've already squared the radius. Thank you so much. I'm almost at 300. All right, we're getting closer. Woo! Right? Only many more to go before I can retire. Okay. Oh, did I tell you guys, was it in this class when I found this out? I told you about Jonathan at Penn? The Jonathan from last year, Jonathan Cabrera. It might have been in stats when I said this. So I'll make sure everybody knows. So Jonathan, he might watch this. What up, Dad? Jonathan, he's not going to. Jonathan Cabrera is at Penn now. He was a senior last year. And he sent me an email because he was telling me, updating me on his math journey at Penn. And he was saying that he even watched some of my old videos. So I was like, oh, that's so nice of you to send that to me. And then he said, and he was even helping his friend Nate. Was it Nate? I think it was Nate. Yeah. His friend Nate by showing the videos as well. And I was like, oh, this Nate guy sounds awesome. Thinking that Nate is a friend at Penn. Well, it turns out Nate is Nathaniel Hernandez, who is a senior here. So I was like, oh, well, still fun, but not as cool. I thought it was like a student at Penn. Because then if I make it through the Ivy Leagues, oh my gosh, I would have so many subscribers. But I don't know about that one. They don't need me. Okay.
Us being subscribed is not enough for you?
You're not even subscribed.
I'm so sad right now. Okay, let's do the antiderivative of these three terms. Same thing I just did in the last one with x to the sixth power. I'm going to write down 1/5 x to the fifth power. Plus, be careful with this one. Here's my process. I write x cubed, right? Everyone, make sure you're hearing what I'm thinking. This 2 up here in the power, 2 plus 1 is 3. Then I'm thinking, what's the reciprocal of 3? What's the reciprocal of 3? 1/3. So I normally would put 1/3 here, but what's already there? A 2. So I do 2 times that 1/3 and give me 2/3. You should have already learned that. I'm just trying to help all my subscribers make sure they know what they're doing. And what's the antiderivative of 1? We're going to evaluate this at 0 and 2.
I'll subscribe.
Thank you. With both accounts, please. Now, is this 0 going to make me happy? Yeah, it is, because 0 to the fifth power, 0 cubed plus 0, all that's going to be 0. That does make me happy. Okay. Don't forget to multiply pi times all that once you're done. I only have one. Oh, you mean you have your own? I have 5 of them? Subscribe them all. Let's do it.
No, when I was in that, I was in 1.
How little is little? I'm concerned.
I was like, I recorded this video. He was like 2, but then beating up his SpongeBob toy. It was like the most random thing ever. Just beating up.
Just needed to get out some feelings. Okay, 2 to the 5th power. What's 2 to the 5th power? 32. That's 32 fifths plus, what's 2 cubed? 8 times 2 is 16 thirds plus 2. What's my common denominator to get all these to be the same? 15. So I'm going to write 15 here. What's 32 times 3? It's not. What's 30 times 3? 90. What's 2 times 3? 6. It's 96. So come on, you can do this. What is 16 times 5? What's 16 times 4? 16 times 4? 64. Add another 16. You get 80. Man, I love math. Okay. And then this is going to be 30 over 15. Again, do I expect you to do this by hand when you're practicing? No. No, I do not. You can go ahead and add or put this in the calculator to get your answer. Just don't forget to multiply by pi. Okay, so what's 80 plus 30? 80 plus 30? 110. Then my brain did 110 plus 100. What's 110 plus 100? 210. And then I subtracted 4 because I went too high with that. So what's 210 minus 4?
2.
Why do you make it so complicated?
Was that complicated? Oh man, that was not complicated for my brain.
Just add them.
Oh my God.
So I guess the way my brain, all brains are different, but what my brain is thinking is for my subscribers again, Georgie, is that 80 plus 30 is 110. And instead of adding 96, I'm going to add 100. I know that much faster, which is 210. Okay, so our brains are different. You can totally do that. I went to 100 because it's closer, and then I subtracted. But how is it any different? Okay, all right. Your way's faster. Your way's probably faster for your brain, right?
Your brain is different, bro.
No, it's a good thing. We're wired differently.
You're so cool.
All right, let's do one more. I agree, you are. Let's do one more. I wouldn't yet unless you're gonna it's gonna be an emergency. Yeah, I would wait till after this, personally. But it's your call. Okay. It's just on the backside. So I know it looks like there's a gap, but there's not because we are going around y equals 12. And here's my favorite part of this. Do you guys see what the function it is? It's the natural exponential function. Woo! You thought you'd get out of here without doing some E. Okay.
Wait, what? Oh.
The letter E. All right, so I'm going to find my radius. That's why we're doing it, which is the distance from our axis of revolution. That's 12 minus, what is our function? 2 times e to the power of x. God, they love you so much, Edwin. Okay? You okay? Your stomach hurts? Then stop eating the treat you're eating. Oh, you can't. All right. I'm going to square this. Using the same way we just did it. Another hat tip to Anita for remembering the middle. What's 12 squared? 140. Very good. All right, I'm going to do the last part first. So this is negative 2e to the power of x squared. So what's negative 2 squared? 4. And then do you know what e to the power of x squared is? Nice. E to the power of 2x. Well done. So I'm sorry about your stomach, but good job. Okay. The middle term, you multiply them, and then times 2. So 12 times negative 2 e to the power of x is negative 24 e to the power of x. But then times 2 is negative 48 e to the power of x. This is my radius squared. You do need to multiply by 2. Go ahead, Kyle. Sorry. I can't. Like just the middle term? Yeah. So you multiply the two terms. So multiplying these together, 12 times negative 2 gives me negative, I'll put it up here, negative 24 e to the power of x. but then times 2, because there will be 2 of them if you were to distribute it out. So that gives you the middle term. You're welcome. What do you- Great question. You're not yet. I'll tell you when you can use the calculator, but not yet. It's coming soon. All right, so let's set it up. I'm putting my pi in front because I'm integrating the area. Okay, and then don't forget to put what we just found, which was our radius squared. And then here's my favorite part of the whole problem. What are my limits of integration?
0, 0.
No, did you hear it, Eduardo? You hear what he just said? He said 0 to like. Is that how we deal in calculus? To like? No, we need what? I need no like. What is the opposite of like?
Unlike.
Exact. Nice. Unlike. Appreciate that. That was helpful. Exactly. Right? Because I think what you were saying was right here, right? You were about to say like 1.8, 1.9. Is that how we can deal here? No. So how do we figure out the exact value? Because you're right. It is 0. We don't give up. What do you mean by plug in?
Plug it into Desmos.
Can't use Desmos here.
All right.
How do you find that point I just plotted right here in the corner? How do you find this point? Oh, yeah, you know?
Don't you find them by plugging it into the original equation?
You find the point by getting the function, and then
Because they're thinking way too hard. Wait, I am going to use the original. Which one? Why don't you guys tell me more? Like, what do you mean? You're getting closer. There's no plugging in. Oh, Julia did it! Go ahead. This will tell us that point. Because if you notice, what I plotted right here, what is that called? The intersection of those two functions. So to find out where that is, I set them equal to each other.
wow.
It's so calculus, but not, right?
Unnecessary.
It is necessary. We need the other limit of integration. Move the 2 over. What do you get when we move it over? You get 6. Okay. Now, I've told you guys, and hopefully you remember this from last year in pre-cal, but if you do not, if you have a variable in the exponent, right, how do I get it out of the exponent? The flip thingy. I'm not sure if anyone in here would know. You can do. I mean, I'm not sure what you're talking about when you say the flip thingy. Like, is it gymnastics? I don't know what you're saying. There is a flip thingy that you could do, but I think no one in here is going to know that. But I do think people in here know what I'm asking about. There's something I can do to get this out of here, and it's in one of my things up there.
Root of x.
I need to take the natural log of both sides. All right, here's why. Watch what happens when I do that. Yes, well, whatever you do to one side, you have to do to the other, right, Georgie?
That was a good question.
Okay, now do you see where this x is? Do you remember what property allows me to do something with that? Yeah. No, I mean, that's a fun word, but what are you doing? What am I going to do with this x?
Put it to the side.
Be more specific. Bring it to the
front.
Bring it to the front is right.
I was right there. No, you were not. Yes, I was.
It's okay if you're confused. This is from pre-cal. Does anyone know the natural log of e?
1.
It's 1.
Oh my God.
So if that's 1, then what is x equal to? Nope. What is x equal to?
ln 6.
The natural log of 6. Please don't say ln, right? Say the natural log of 6. At least you didn't say in. That makes me even more upset. The natural log of 6. It's because when they did this, they were using Latin, which is a different order.
Why isn't it just NL though?
I just answered that question.
Latin, bro. So it's like low natural.
Yeah, I'm not going to try to speak it because I don't know Latin, but it's like a logarithmic natural or something. I don't know how they said it. I don't speak Latin?
Logos naturale. Latin?
Sure.
That's Latin.
What happened?
I might be the Pope.
The E is now my argument. Is now my argument of the natural log, and the natural log of E is 1. So that's why I put that. If you guys saw where I put it, I put this that you found as my other limit of integration. That was exciting. That's one of my favorite parts of the problem. We're not done yet. Let's get started. Okay.
The thing is, natural log of 6.
I know, right? Which is approximately like 1.9, but I don't deal with likes. I mean, I do, right? Like and subscribe. But I don't deal with approximates. Thank you. Thank you. Appreciate it. I'll be here the rest of the week. Okay. Let's find the antiderivative. You ready? What's the antiderivative? Yes, Kyle, sorry.
Could you plug in the natural log of 6 into the calculator to get like a better?
Better? Oh, is it better to get a decimal? Are you speaking ill of natural logs? Because John Napier would be very mad.
Who likes natural log?
I can find it.
The guy who came up with logs. Technically you could, but you'd be using. Shh, it's a good question. You'd be using a rounded version. Just make sure that when you do the plugging in, that you're plugging in the not rounded version, because I don't want you plugging in rounded values. Okay. All right. What's the antiderivative of 144? 144x. Okay. Now, do you guys remember? Because Alan, you need to pay attention. You said you always mess this up. What I'm going to write is e to the power of x. When I take the derivative of e to the power of x, what do? You copy it, and then you take, what a chain rule, Julia, I love it. What's the derivative of x? Just 1. So this is literally exactly the same. I know.
So if it's like, so say it's like x squared.
E to the 2x power, is that what you're saying? Oh, lucky for you, that's about to happen.
Wait, because the derivative is the same.
But it's chain rule times the derivative of the power, and the power is x. The derivative of x is just 1. So that's why it looks like it's the same, Georgie. But be careful, because right now, this is what Alan's just asking. If I took the derivative right now, I would copy it. What's the derivative of 2x? 2. But what do I have there? So I need to put another 2 here, because 2 times 2 gives me that 4. That's how you do that. And now you're going to evaluate this at the natural log of 6 and 0. Okay, is this 0 going to make me happy?
No,
Oh, wow.
No, because hit him with a guy out. Hit him with a guy out because
e to the power of 0 is 1.
What up? Well done, Kyle.
What?
My goodness. Don't forget at the end to multiply by pi. I can show you if you want, Valeria. At this point, I could actually, once I write this in, I could go to the calculator and just type all this out. It'll give it to me. So if you want to do that later, we can. Okay, so here we go. Pi times, here we go, 144, hopefully you're writing this, times the natural log of 6. Let's put parentheses there. Minus 48 times e to the natural log of 6 plus 2 times e raised to the 2 times the natural log of 6 power minus 144 times 0 minus 48 times e to the 0 power plus 2, oh, that's a shame, times e raised to the 2 times 0 power. Okay. Is that what you're going to do on the AP exam? Oh, I ran out of space, so I'm just not going to do it.
I'm not sure. If I see L, N, or E in one of the questions, I'm doing it again.
Oh, I need my... I'm going to stop here because my computer's about to die, but I just want to show you, for people watching and subscribe to my channel, I'm going to be typing this into Desmos to get the final answer. Good luck.
Bye, subscribers.
You can subscribe.